Hello, it's David. This is my PiStorm. We've discussed this a few times, although this is a slightly different board. This is a Pi 3A, whereas previously I've been using a 3B. So this is stacked some way off the PiStorm itself, causing this to be a bit of a tower of terror. It's already on an adapter. This is my STE. Now I'm sorry I can't really show you this in particular close up. Everything's a little bit squashed at the moment in the shed. We've got an absolute mess everywhere. Falcons and STFMs in pieces and Amiga 500s under my keyboard and a disk drive over there and my STEs down here. And you can see that I'm a little bit rammed. I'm a little bit tight for space at the moment. But there we go. Look, you can see that I've got standoffs in there on that PiStorm, and I've got a debugging board in there, and I've got an adapter, and nothing really fits very well. But I want to see if I can get this up and running with my Pi 3A plus, and you can see there we go. Look, we've booted up to the desktop. I can move the mouse around, run Genbench. It all seems relatively happy with the one issue that I've broken bus arbitration a little bit. It works okay for the floppy, as you can see. And you can see here that the integer division figures are still absolutely fantastic, as they do tend to be on the PiStorm. There we go. I think we've got just the 1,212% at the moment. But anyway, other people are having problems getting this working, and I'm worried that I just have a particularly unique setup that just happens to work. So my plan for today is to build a new PiStorm board, plug my 3A into it, and have it nice and flush and the way that the designers intended. Well, this is our starting point today. I've bought a partially assembled PiStorm PCB. Now this has some of the tiny little passives. You can see C1, C10, C13 there. Some capacitors around here, capacitors up here. All in place. It's a single-sided load, obviously. It's also got the two level shifters here, which deals with the communication between the pins and the CPLD, the ones that don't go through the latches. But we need to solder on our header, our voltage regulator, our 4 latches, and well, this looks the least convincing of all, doesn't it? This is what I've received from eBay. I've got 2 CPLDs, not exactly static safe. They're wrapped up in a bag, so fingers crossed we can get one of them to work. I also need to put on the header pins. Hopefully I've got some of those in my big header pin jar. Yep, no, I've got plenty of those at least. So that's our first task. Let's get this soldered up. And if we pop that to one side for a second, we'll just have a quick look at what we've got now. So this is what's just come out of the STE. So we've got the adapter board that we designed before. We've got the 68K debug board that we designed before. There's the PiStorm with the extended PC104 header and the Raspberry Pi 3A on the top. So let's start by deconstructing this a little bit. There we go. And let's pry that off while we're at it. Just be careful when you do this, just be careful what you're prying against. I happen to know that there's nothing under there, but that can cause trouble when taking those loose. So this is what I want to get to. But what I want to do is to not have this elongated standoff here because the Pi 3A doesn't require that, and when that slots together there, it should actually ride down low enough. There we go. That it. Oh, sorry. It should ride down low enough that it doesn't require that additional clearance that the Pi 3B does. Okay, my starting point is going to be the CPLDs. Normally is, because these are the most likely things to get wrong and therefore have to start all from scratch. Let's see if we can get into this completely non-static proofed packaging and get one of our quad flat packs out. I think this is pallet wrap. I think this is probably absolutely guaranteed to generate static electricity. There's our Altera Max 2 EPM 240 of dubious provenance. EPM 240T 100C5N. So that's what we're going to start with. Let's see whether we can bring this into play. So pin 1 with the white dot. Corresponds to the dot on the chip. This one is relatively nice, it only has one dot on it. You get some chips with multiple dots, then you've got to try and figure out which one is in fact pin 1. So actually I think I've done a relatively decent job with the alignment there, just by complete guesswork from miles and miles away. But this is the bit, spend a little bit of time trying to get things lined up, and then what we'll do, we'll bring in our little blob of solder, and I'm going to be using my K-tip soldering iron set at 290, and we'll see what we can do about this chip. I think that is pretty much perfect. Right. So a big old blob of flux. Equally big old blob of solder on the K-tip here. And we'll bring the two together. That should anchor that corner. We'll spin the board around, double check our alignment, and repeat the process. I'd say that's pretty good. One trick, if you don't have suitable magnification for this, is if you're not sure, get out your phone, zoom it in nicely, take yourself a snap, and actually you've got a pretty good microscope right there on your telephone. So what you normally end up with when doing this is, if you start at this end and drag this way, you'll probably end up with a short or a ball or something similar right on the last couple of pins. There may be one here, just as I look at it. And the trick is, you just clean the end a little bit of your soldering iron, and you just bob in and out a touch. If there's an excess, the cleaned iron will normally pick it up. In fact, I've probably over-cleaned that, and I might have to just reintroduce a little bit more. But it's just a case of getting the balance right. The flux will really help you there. There we go, look, there's a little bit of excess. There was. And it's gone. I think that one's fine. Just a case now of repeating that for all the sides. Okay, so this is the first example where I've used an excessive amount of solder and we end up with this enormous blob at this end, and you can see it's just massively shiny and over reflecting and hard to pick up on the camera. So this is the example that I was mentioning before. We make sure the tip of our iron is nice and free from solder, and we will just bob in and out of this a few times. Possibly only once. You see the end of the tip picks up that excess solder. Okay, we're going to move on to the latches now, and these ones might be a little bit harder, surprisingly, even though they're only two-sided, because as we solder down the pins on this one, we're going to start impinging on the pins on this one. So I'm not sure there's actually a good way to do this. I think we'll just take our latches out and we'll get on with it. So in this particular case, pin 1 is indicated, or the end for pin 1 is indicated by the cutout here, and there is also a dot. So this should be relatively straightforward to identify. Our chips don't have the notch at the top, they've got the dot, so that'll be there, or there. They're all in the same orientation by the look of things. So I'm going to start with C3 here so that I can work on this inner row first, I think, because I think that's going to be the more complicated one in the long run. So same as before, we'll just do a rough alignment and then tack a corner. Well, sorry, that took an inordinately long amount of time to line up because it just kept slipping off the pads. Not, you know, the low energy position is to slip between the pads, which is annoying. But there we go, I think that one's anchored down. I'm in two minds whether to solder that on all the way or to anchor maybe C2, sorry, U5 here next to it as well to kill two birds with one stone. I think if I come over here and do U6, I'm just going to interfere. So yeah, I think I might anchor down U5 first as well. Okay, I've run into a problem there. So I anchored it, this corner was out and I couldn't get it back in. I tried to remount the anchor and move it, and now the entire thing has skewed and I've got a big blob of mess. So I'm going to have to go in with the desoldering braid and see if I can loosen this up again. Alright, I think I'm going to have to get the hot air on that one. So set my hot air for 350. I'm not going with too high a flow rate because I don't want to blow everything away. Don't want to knock all the passives off. But I'm going to have to see if I can slide this to one side or lift it over. Goodness me, that one really fought hard. I think it's pretty much aligned though. Let's look at the mess. Let me, I'm just going to solder that quick before anything moves. I started on the wrong side. Fool. Don't start drag soldering on the side that you're anchored. That's schoolboy error. I've done those again off camera because it's just so damned fiddly. Just tacks down. Let's get them soldered. Yep, so I think this is where we will just bring in a little bit of braid. So just a little delicate dab. Oops. Well, you know, I don't think we're going to be completely sure until we've cleaned all those up. But what a nightmare. That was actually a lot worse than I was expecting. I would not recommend doing more than a few of these by hand, that's for certain. Okay, so what's next is the voltage regulator. Now, there are places for 2 voltage regulators on here. Now, depending on the type of chip you have, you may require one or the other. In our particular case, I believe we only need I think that's U, does that say U8 or U6? U8. So I think we only need U8 for this particular one. So our voltage regulator, I believe that's a 1.8 there. This is meant to be a 3.3. That's a 1.8. If you have a CPLD that requires a 1.8 voltage line as well, then you need both. I think my 240C5, was it? Can't read it. But I believe this one only requires the 3.3. So this says O3RP NO5A. Bit of flux. We'll place our regulator. This one's going to be a lot easier to do. Look at the size of the footprint. I'm going to start over here. Same idea, big blob. And go for the middle pin, I think. Try and hold it down. Pin and pad at the same time. That takes a little bit longer to melt, but there we go. Good firm contact. Then I'm going to spin it back around and I'll solder down the big tab at the back, which will make sure it's nice and flat. There we go, pad and tab. Good solid contact. Now, come back around to this side, reflow the one that we've already done, again pressing down, just good to be belt and braces, and we can just finish off the other two quite quickly. Starting on the pin, just to heat the pin up. Then sliding down onto the pad. Make sure we have a good solid contact. So all we're left with now is our boring through hole. Remembering that the Raspberry Pi mounts on the chip side, so this needs to be on here, and then we need to get our pin headers in. Or do we do our pin headers first, maybe? I think perhaps it would make more sense to do our pin headers first. But because I'm now moving on to through hole, I'm going to take a break there to allow my soldering iron to cool down and switch to my chisel tip. So this has had a chance for a little soak, and it's come out looking a little bit better. Still not perfect, I haven't dried it very well. Yeah, our friend there, U5, is a little bit drunk. If we need to, we can always heat that up with hot air and it will probably suck itself into position, but I think when we have a look later on, I think it's all going to be fine. Perhaps this little corner of the CPLD down here needs a bit further inspection. Maybe just a little bit dry there. That might do with a little bit of a reflow. But anyway, it's not turned out too badly despite all of the effort. So we've got our header pins here. This one's a bit bent in the corner, but we can, well, we don't necessarily need that one anyway. We can start the other end. So let's get the header pins in, and then we'll get our socket in, and we will be good to go. Just going to use the other header there to hold these straight while we tack them in. And like I said, today I've shifted over to the chisel tip for this through hole work. I'd like to thank this video's sponsor and the supplier of my project PCBs, PCBWay. PCBWay aren't just about PCBs either, although they are extremely good at that. They also offer component assembly, CNC machining, 3D printing, and a variety of other manufacturing services. They have a number of community-focused offerings too. The Shared Project Hub is an open platform for makers to share and exchange their ideas, and the PCBWay store is a great place to pick up assembled modules. I mean, who wouldn't want a musical Tesla coil? So many thanks again to PCBWay, and I recommend you have a look at some of the links included down below. I found that a little bit difficult to do that side with my normal temperature iron and with the liquid flux that I'm using here. So I've gone with my syringe flux here, my paste flux, and I've turned the iron up to 350, and we'll see whether I can do this header row any more easily. Okay, and we'll just break off the unused ones at the end here. Made up pretty straight to me. That's pretty good. And we need this one popped in here. I do so hate soldering through hole. Sorry about any background noise that's coming and going here. My neighbour's having some work done. It's the weekend. Right, just bringing in the continuity tester here. First things first, let's make sure that we haven't introduced any shorts. We don't want any short between ground and VCC. So first place to start is our voltage regulator. Nothing between those two. Well, 650, 400, 500, 670. No direct shorts there. Let's have a look at our ground and power pins. Yeah, we had a brief capacitive charge between the 5V and ground rails there, so I think that, and then obviously settle down to open loop, so I think that's fine. Let's move on to the stack assembly. So here's our Raspberry Pi 3A Plus. This mounts this way around. I don't believe there's any indicator on here. Pin, is that a pin 1 indicator down in the corner there? Yeah, there we go. So pin 1 there, and on the Pi board, pin 1 there. So yeah, that coincides with being mounted in this direction. They snap together quite easily. So that's the profile that would work inside an A500. I do have one here. I may get around to trying that at some point. So this is the pin 1 indicator here. On my adapter board, pin 1 indicator is here. So this one I'll slot in this direction. Make sure our pins seem nice and straight. Yep. There we go. So there's our entire adapter plate. So I very much doubt this will work first time. I suspect we will have to do some reflowing, but I'm going to get the STE out, mount this inside, and just do another continuity check on ground and power, I think. Okay, so the STE is back on the table. Here's the CPU socket, which we will interface with just here. Feel for the alignment, and then try and apply equal pressure. Maybe I've not got the alignment. Yeah, I'm pretty sure that is right. Apply equal pressure. There we go. Nice positive contact. Now presumably, you know, if I was to use this forever, that's not going to be stable and needs some support, but this is absolutely fine for testing. Can't put the keyboard in here anyway. That's out to one side. So let's get that continuity check done. Just using the cheap eBay meter here today as my my main multimeter's off, being tasked with another job. So we should not have any continuity across this cap. There'll be the initial charge up, which is a big cap. There it goes. And there we are. Then we get about 230 ohms across the whole board. So that's pretty reasonable. It's actually probably higher than I was expecting. So that would imply that we don't have any direct shorts on the PiStorm itself. Right, so let's throw the power switch. Keep an eye on the power LED up here. If anything starts smoking or goes bang, I'll turn it off quite sharply. Otherwise, we'll be waiting to get a ping response from the Raspberry Pi. Green light, flash, got a red and a green flash down here. Can't smell any burning, so let's turn our attention to our terminal and keep an eye open for that ping reply. We've got a ping straight away. Helps to remember the password. Right, so let's be brave and try running the emulator. I'm not expecting much first off, but why not? Okay, that's what you see if the state machine hasn't initialized. So I'm just going to hold reset for a couple of seconds. Try that again. Yep, I'm not seeing anything. Oh, I haven't programmed the CPLD yet. Okay, so we run nprog. That might have something to do with it. And we'll try again. Okay, lots of bus errors. Okay, so that particular test failed, but slowly. Let me try this one. Okay, now this is reading chunks and writing chunks, reading them back and checking for any errors. You can see here the cumulative errors total so far is 0, but I would expect something on the screen by now. So I'm writing data to the registers. I would expect something to come up. Whether it's because I've got a mono monitor and it has to initialize it to mono, that could be a factor. But that's good. I'm not seeing any errors. So let me try running the emulator again. No, still lots of bus errors. Now, what I have prepared is a version of Emutos that does not require any DMA access because I've been seeing some problems with my bus arbitration logic. So why don't we try running the no DMA version of our operating system and see whether we get any joy here. Still the same bus errors, just press reset. The bus errors stopped, still not seeing anything. Ah, okay. Oh, so it took a few. Okay. So it took a few goes, but we are getting slight progress, and oh, nearly got the Emutos screen. Wow. Okay, that's interesting. Let's just Control-Alt-Delete. It's trying to work. Now, I don't know whether that would indicate an intermittent fault or whether this would actually be the problem that I've been trying to identify that the other users are seeing. It's complaining a lot about bus errors. Okay, so I think we're going to leave that there for today. On the face of this, this might appear to be a failure. It's not working. However, it is exhibiting very similar problems to the ones that the guys on the Discord channel have been experiencing. So it could very well be that this PiStorm that we've built is actually a better representation of the normal ones out there in the world than this one that I bought complete from a seller. So I think I'll have a go at reflowing this anyway. It does need to be cleaned up some more. It's possible that just there's some low resistance pathways or something here. But if this genuinely is representing what other people are seeing, then I can now start working on the firmware and hopefully we can improve people's experience. So this is what I wanted. This is a test bed. Actually, this is mostly a success. Single thumbs up. I'll see you in the next video.